Okay, let's have a look at this then. Angles greater than 90 degrees. So if you draw a unit circle, and here's a triangle with an angle theta, you see the opposite sine is opposite over the hypotenuse, which is 1. So that this height then, because it's divided by 1, is just going to be the value of sine theta. And the adjacent over the hypotenuse, this distance here, the x-coordinate distance, is going to be the cosine, isn't it? Because it's adjacent over hypotenuse, so that length is the cosine. So when we draw this picture, we can see what value the sine and the cosine has. Sine is the height, y-coordinate, and cos is the x-coordinate as p moves around. So for example, let's just look at sine and cosine then and see how the sine changes. As p moves around this bit here, the y-coordinate is always positive. And then the height is negative underneath, isn't it? So sine is positive here and here. Or A stands for all. So they're all trig ratios are positive here, and we just said the sine was positive here and here. Sine is positive, so that stands for sine. And then, so sine is positive here and here, and negative there and there. And let's have a look at cosine then, shall we? As p moves around, we can see that the x-coordinate's positive, negative, negative, positive. So cosine is positive here and here. See A and C? So that's positive there. And it's negative there and there. And then the tan, I'm not going to worry about the tan because it's just the ratio of sine over cos. But you can just check in each quadrant that it's going to, because they're both positive here, tan is positive there, and tan is, because they're both negative here, tan is negative over negative, which is positive. And tan is negative here because sine is positive, cos is negative. And cos is positive, sine is negative here, so tan is negative here. So this word's cast, which we write as C-A-S-T, tells us when the trig ratios are positive or negative. It basically tells us that when they're positive, so sine, for example, A stands for all, and S stands for sine. Sine is positive here and here, and if it's not positive, it's negative. So this little picture, word picture, tells us the sine's negative here. Cosine is positive where they're all positive and cos is positive, and that if they're not positive, they're negative, so they're negative there. Tan is positive here and here, because they're all positive there, and tan is positive there. And if they're not positive, they're negative, so they're negative there and there. So I hope you can see the picture, best explained by examples. So let's get straight into some examples. Solve between 0 and 360 then on this circle, this trig ratio. So what you do is you draw a circle, you right cast, and you read off that sine is positive, and you tick the quadrants because you know it's here and here with the A and the S. You draw two lines, you mark off an angle called the associated acute angle. So alpha is the associated acute angle. Okay, that's what you do. So we ticked off the two quadrants, we drew two lines in those quadrants, and we marked off alpha, the associated acute angle, the angle the line makes to the horizontal. It's always that, okay? And then we simply write sine alpha, and we drop any negative in this number if there is one to drop. And then we do shift sine, inverse sine of 0.7 to work out alpha. So shift sine 0.7 in degrees mode because we're working in degrees. So shift sine 0.7. 44.4 we'll do to 1 dp degrees. So now once we know alpha, we can read off the solutions for theta, x rather. We're going from 0 to 360, so our first solution in the picture will be around to here. So x is equal to, round to here would be this angle 44.4, wouldn't it? And then the other solution, we have to go right round to this other line here. That's 180 back the 44.4. So 44.4 then, and 135.6 degrees. Okay. Good. So the next one, let's do this one. Cos x equals 0.3. Draw a circle then. We get used to these by examples. Right, cast. It's the same every time. Cos is positive, yeah? Cos is positive here and here in these quadrants. You draw two lines. You mark off alpha, the associated acute angle, from the line to the horizontal. And you simply write cos alpha equals, and drop any negative. So it's just 0.3. Shift cos, 0.3. We'll do it to the nearest degree now. Oops. Shift cos of 0.3. 72.54. I'm going to do it to the nearest 1 dp. 72.5 degrees. So we can read off x then. The first solution, we're going around from 0 to 360, aren't we? So let's go around to here. And that's simply around the angle alpha. 72.5 degrees. The next solution, we go around from 0 right round to here, which is around 360 back the 72.5 degrees. 72.5 degrees then. And 280, 87.5 degrees. Okay, good. That's that one done then. Now we'll look at the next two. And we've got tan x equals minus 1.9. So it's the same again. Draw a circle. Right cast in the correct places. And then tan is negative. Tan is positive here and here, isn't it? So it's negative there and there. So tick those. Draw two lines. Mark off the alpha, the associated acute angle to the horizontal, and simply write tan alpha equals, and drop the negative if there is one to drop. Same process every time. Shift tan 1.9 in degrees mode, and we can get that. Shift tan 1.9. 62.24, 62.2 then. So that's alpha. So we can read off x then. Our first solution is round to here. 180 back 62.2. And our next solution is right round 90, 180, 270 round to here. Round 360 back the 62.2 degrees. So what have we got? We've got 117.8 degrees, and we've got 277.8 degrees. So that's that one done. Okay. Bit worried about this. Oh, 298. What am I talking about? 297.8. Yeah, that's right, because 60 is 29. I don't know how I managed to take off that many. 297.8. Okay, next one. Now the interesting thing is 0 goes from x to 360. But we're not solving for x, are we? We've got a sine of 2x. So the range for the angle, the sine of that angle, double this, double this, double this on the inequality. So we actually have to go around, as far as 2x is concerned, right round to 720 degrees when we're solving this trig ratio. So this problem is slightly different. Let's have a look at it then. Draw a circle. CAST. And don't forget we can go round twice, right round to 720. There's 0. We can go round twice round the circle to get our solution set. So sine is positive. It's positive here and here. Draw our two lines then. Mark off alpha. And simply write sine alpha is equal to 0.4. Drop the negative if there is one to drop. Shift sine 0.4. Shift sine 0.4. 23.6. 23.6 degrees. So let's work out our solutions for our angle. Now this time our angle is 2x, so 2x is equal to then, let's go around to the first one, 23.6 degrees. And then the next one is round to here, 180 minus 20, which is 156.4. That's that one. Then we can go right round here, 360 to here, 360 plus the alpha, so that's 383.6. And then we can go round, believe it or not, I'll do it a different colour so we're absolutely clear. We can go round once to 360, 450. We can actually go around to 540, back to 23.6. So it's 540, I'll just put it up here. Back the 23.6, just to work it out. It's 516.4. So 516.4. And then we've gone round enough times, haven't we? Because there's nothing under here, and that's round to 720. So we've gone right round for the angle to 720, and here's all our solutions. We need to solve that. That's 2x, so we need to divide it by 2. Now 23.6, let's get the angle. Divide that by 2. What do we get? 11.8. And then we get 128.7. No, 78.2. Sorry. 78.2 degrees. And then we get 383.6. 383.6 divided by 2. 191.8. And then the last one, 516.4 is 258.2 when you divide it by 2. So we've got 4 solutions. And the nice thing is, problems like this, we can try them, tap them in and see if they're correct. So we can check all these are correct, you see. So sine 2x, sine 2 times sine of 2 times 11.8 should equal 0.400, 0.4. Slight error term because we've approximated to 1 dp, haven't we? But you can check your solutions are correct as well.